Alright, here we go.
What did you just do?
We're recording because of fun. Let's all say hi to Savannah as she's getting her legs amputated. Hi, Savannah.
Hi, Savannah.
Hi, Savannah.
We tried not to do math in your honor.
I'm going to die here.
But it didn't work.
Kane's gonna kill me.
But Kane's a big meanie. Alright.
She already knows that.
Yeah, I know.
I'm not even listening to this.
She will.
She's
She
not
will.
yet.
We should live stream
She's
her.
watching it right now.
We
It's a
should
live stream.
video chat her.
Oh, it's a live stream?
No.
Yeah, no. Are you
Oh.
kidding? I'm not that fancy. Alright, anyways, we are going to practice using examples from page number 762. And your homework is going to be the evens.
Up to what number?
All of them. Here's number 3. Now the directions, I'll read them to you. It says the position of an object at the time is given by the function s of t. Find the instantaneous velocity at the indicated value of t. So for number 3, s of t, so this is a function, f of x, same thing, equals 3t minus 5. And it asks for the instantaneous velocity. But what this gives, this is a function of position. So a derivative is slope, and a derivative of position gives a velocity, because that would be a rate of change. If I have your position and I find, well, how quickly are you changing your position, your rate of change, that would give a velocity. And then if I took this answer and I did a derivative again, I would be asking, well, how quickly is your velocity changing? And that would be an acceleration. For the most part, I'm pretty sure that your book is going to focus on this one, using a position function to get a velocity. So for number 3, it wants the derivative of the position at time 4. Now, just for ease, because s's and t's are going to be confusing, I'm going to go ahead and change it to f of x equals 3x minus 5, just because we're used to that. But x is representing a time. And what we want is the velocity at time 4. So we're going to have to find the derivative, the instantaneous velocity at point 4. So there's a few ways we can do this. What we're going to do is we're going to find the derivative at all the points and go ahead and find the instantaneous velocity. Now, you should recognize, we are going to do all the work that's involved with that, but you should recognize that this is a line. And since a derivative is simply the slope, no matter what point, I could put any point in here. I could put -7. Not that that makes any sense, because that would be time -7. I could put any point in here, and it doesn't matter. The velocity is always going to be the same. It's always going to be 3, because this is the slope. Alright? But we are going to go ahead and do all the work involved and just show that it would be a 3. So, the way to find a derivative is going to be to take the limit as h approaches 0 of f of x plus h minus f of x all over h, because the x's would subtract. This is basically a slope equation, all right, that we saw yesterday. So we're going to take this in, and we are going to find, well, what's the f of x plus h? Well, that means I'm replacing this with x plus h. So that's going to be 3 times x plus h minus 5. And I'm going to go ahead and simplify that to 3x plus 3h minus 5. And then f of x, I know what that is. That is this 3x minus 5. And then I'm subtracting them. I'm just going to go ahead and do that work right here. So I do this, subtract this. So I have 3x plus 3h minus 5 minus quantity 3x minus 5. It is important that you put this in parentheses because that minus is going to distribute. And we have to get this h to cancel because it's 0, and that's going to cause us to have some problems. So we distribute, so we have 3x plus 3h minus 5 minus 3x plus 5. Switches signs. And let's take a look at what cancels. Those cancel, opposite in sign. The 5s cancel. So that leaves us with 3h over h. And notice what else cancels? The h's. So the limit as h approaches 0 just happens to be 3. So no matter what we put in here, we do get a 3. Now this works if it's a line. So if we take a look at number 5, which we'll end up doing on the next slide here, but number 5 is asking the same question. I'm going to change to fx. So fx equals ax squared plus 5 at x equals 2. Okay, now we have a little extra thing here. We have this a, and this a is a constant. Now, yeah, it's a variable, but it's representing a constant. So we're basically finding this derivative for, well, what if this were any particular number? So what we're going to find out is that that derivative is going to be 2ax in the end. So we're going to get, our answer is going to be 4a. All right, let's take a look at that. We're going to do that one. So f of x equals ax squared plus 5 at, so we want f derivative. This is not inverse. Notice there's not a negative there. So the derivative of f at 2. Okay, so we're going to go through all those steps. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Again, this is just a slope. Now, how is this a slope? Because yesterday we talked about, well, slope is change in y over change in x. And we're taking this limit as h approaches 0. We want this the slope of the tangent line. So if we have like a function that looks like this, and we want the instantaneous velocity at this point, or we want the slope of the tangent line at this point, well, in order to do slope, we need 2 points. So we take these 2 points, we connect them, we find the slope of this line connected them, and what we do is we take this little point and we move it closer and closer and closer to the first one, okay? Until it's so close that it's on top of it. And the way we represent that, well, that would be x plus a little bit more, minus x, all over, or under, f of x plus h minus f of x. So f of x is representing y's. And what we see in this denominator, well, where the x's go, well, the x's are always going to end up canceling and leaving me with just an h. All right, so here's our function. We have to put in this x plus h. So f of x plus h equals a times x plus h squared plus 5. And then I'm going to expand that. So I leave that a up there. I get x squared plus 2xh, I'm pretty sure, plus h squared. And then I have my plus 5. I can distribute that a. So I get ax squared plus 2xah plus h squared plus 5. And then I have f of x. So I'm going to take the limit as h approaches 0, and I'm going to put this in. So I have ax squared plus 2xah plus h squared plus 5, and then I have minus a quantity, and that's going to be this, f of x. So that's ax squared plus 5, all over h. And I'm trying to get it so that the h's cancel. Now I can't just cancel right here, right? Because I can't cancel through addition and subtraction. I have to somehow factor out an h. All right, so if I distribute that negative, hopefully you see that this becomes negative ax squared, and that becomes negative 5. So in the end, what will happen is these cancel. So that's going to cancel. The 5's end up canceling. And that leaves me with 2xah plus h squared all over h. I can factor out an h right there, so I will. And then we can cancel those h's. Now I'm going to take the limit as h approaches 0. So what will I do in order to do that? Because I actually do have an h still in this problem, don't I? How do I do this limit?
Replace h with 0.
Replace h with 0. And I'm going to see that equals, I replace that with 0, and I get 2xa. So now I have my equation for my derivative. The equation for my derivative is this, 2xa. And it says I want that derivative, I want to evaluate that derivative at 2. So I put a 2 in for x, not for a. And I get 4a. So the gist of this is if I change this a to a 3, put a 3 here. If I change it to a 5, put a 5 here. And that gives me the instantaneous velocity at a point. Okay? Any questions on this? All right, I want you to get your calculator handy. Get to regular mode. And make sure you're in degrees, because we'll do this in degrees. Let's say f of x is 2 cosine x. And I want to evaluate the derivative at, we're going to do 2 of them. Let's do it at 45 degrees. And let's also do it at 180 degrees. Okay? So I want to find the slope of the tangent line at this point. Now, the limit way of doing this is not going to work because it will be impossible for me to cancel my h's. So we're going to have to use a different method. And that's where we're going to estimate our derivative by choosing h to be a really, really small value, but not 0. So our derivative, and we're actually going to put in the number. So our derivative at 45 degrees is going to be about f of x plus h minus f of x all over h. And I'm going to choose h to be something really small. Let's try 0.001. I can't do the 0 because I'm not going to be able to take that limit. And I'm not going to get I'm not going to get a function right here. Alright, so sometimes the other method is not going to work. Alright, so we'll choose h as 0.001. I want it at 45 degrees, so I find f of 45 plus 0.001 minus f of 45. So using your calculator, we will want to keep as many decimal points as we can. Let's keep 4 decimal places in this case. Actually, let's keep 5. Let's keep 5. Do 1 extra. Alright, so what is cosine of 45.001? And then don't forget to multiply it by 2. So you want 2 cosine of 45.001. What do we get?
1.41419.
And that's after you multiply by 2?
Yes.
Minus what's f of 45. So we want 2 cosine 45.
Root 2.
Did you multiply it by 2? Yeah, root 2, which is what as a decimal?
What about 2.8284?
I got 1.4.
Oh wait, no. Yeah, okay,
1 point what?
1.41421.
Okay, all over
sorry. I multiplied by 2.
0.001. So let's subtract those. What do we get? I think we get 0.000 what? Zero 2. All over 0.001. Is that correct? Dear Internet, please bear with my students as they learn how to push buttons on a calculator. So you subtract these? Did we get what I wrote here?
No.
We did not. What do we get?
I got negative 2e.
That's what I got.
Okay, negative 2e what?
Minus 0.5.
Minus 0.5. That's scientific notation. So it's saying negative 2 times 10 to the negative 5th. So that means take this negative 2 and move the decimal point to the left 5 spots. So let's see. 1, 2, 3, 4, 5. Yes, it is what I wrote there. Now go ahead and divide, except that it should be negative. Now divide by 0.001. What do we get? Negative 0.02. I need my calculator here. I question your logic.
We question your sanity.
That's not what I get.
What do you get?
Not that.
What's
But
wrong?
we'll come back to it. Okay, so we might have an error possible in here. Let's do the 180. Same idea. So we'll choose H2.001. All right, so we're going to do F of 180.001 minus F of 180 all over 0.001. All right, so we are going to do 2 cosine of 180.001. Okay, that's better. Although we might have too many decimal points. I get negative 2 minus 2 cosine 180. Yeah, I get too many decimal points. 2.001, which is about 0. Probably if we had just used a tenth, yes, a tenth would have been better. But 0. Answer right there. Okay, let's try. We're going to do number 17. So page 7, 62. This is number 17. F of x equals 2x squared. I want the derivative at -1. So we can do this like the way we just did, where we estimate by choosing an h. The directions of the book are asking us to graph the function and to write the equation of the tangent line at the point. So the direction is saying write the equation of the tangent line at the point. That means we're going to need to use the equation of line. Point slope form will probably be the easiest to use for this. And in order to do that, m is going to be our slope. So we're going to need to use our derivative to get that. And x1 and y1 is going to be, see, x1 is our point, so that's going to be -1 in this case. And y1 is going to be f of -1. Okay? Or that's the y value. So let's go ahead and figure that out. What is the f of -1? Well, that's going to be 2 times -1 squared, which is, this is going to be a 1, so that's a 2. So our point, we're doing this at the point -1, 2. Okay, so we can already fill that in our equation. That's y minus 2 equals mx plus 1. Okay, notice that's not squared. This is a line. All right, so we need to get our derivative. So m. Let's go ahead and do it by calculating the. Let's do an estimate. I think that'll be the fastest way, and we can pretty much gather what this is going to be. So our f prime at -1 will be f of x, so -1 plus, let's just do this again, minus f of -1 all over h we're choosing as 0.001. So we're not going to do the limit thing. We don't need the equation. We're finding the derivative. We'll do an estimate. So f of, so we're going to do 2 times -1 point plus -1 plus 0.001. Oh, I forgot to square it. So it doesn't need to be squared. Squared. Okay, I get here 1.996002 minus f of -1 we have already calculated as 2. And we'll go ahead and subtract that. I get, now my calculator pops out -3.998 times 10 to the -3rd. It does that by writing an e. That means move my decimal point to the left 3 spots. And then I'll divide by 0.001. And then I get -3.998. See, now it appears to me, now you want to be careful about rounding, but it appears to me, and I begin thinking that if I continually make this, this approach 0, that this is going to approach -4. So I'm thinking -4 is going to be the slope. So I'm going to use that right there. So y minus 2 equals -4 times x plus 1. I'll go ahead and distribute the -4 so I can get this into slope-intercept form and add the 2. So -4x, add the 2, -2. So that looks like the equation of line in slope-intercept form. Yes, that makes sense. That should be correct. All right, I want to try a harder derivative. Any questions on this, or do you need to see another one where you get the line, the actual tangent line? So this is the equation of the actual tangent line. So if I were to graph this, where's the rough sketch? I would get a fairly steep parabola, something like this. And at -1, what we're saying is the equation of the tangent line is something like this. Okay, it's very steep and going down. Okay, and that would be the line. That's what we just found. We found the equation of the line that we can produce there. Okay. Do you need to see another one where we do that?
Yes.
Okay. So let's do number 19. Number 19 is f of x equals 2x squared minus 7x plus 3. And we want the derivative at 2. So when we're finding the derivative at a specific point, estimates can be faster than finding the actual derivative of this. But just for practice, let's find the actual derivative. So let's find f prime of x. What we'll get is a function. So we're going to say limit as h approaches 0. So you're going to do it this way, what we're about to do, if we want the actual derivative function. What is the derivative at any point? And that's where we're going to do this. And we just put in a generic point here. So if I put in x plus h, I'm going to do 2 times x plus h squared minus 7 times x plus h plus 3. And I just start to evaluate this. I'll distribute that. And then start simplifying. Combine what I can. I don't think I can combine anything. So this is what f of x plus h equals. This thing right here. Now to save space right here, I'm not going to put all that in. I would subtract from that this. So I'm going to subtract from it 2x squared, this will switch signs, plus 7x, that will switch signs, minus 3. So what ends up happening is the 3's cancel, those cancel, those cancel. So I get the limit as h approaches 0 of 4xh plus 2h squared minus 7h. And what are we hoping that we can cancel? The h's. And so we can factor out an h. That's an h all over h. And I'm taking the limit. You can't drop this limit thing. The h's cancel. And now to evaluate this limit, we can go ahead and replace h with 0. So this is going to go away. And I get f prime of x, so this is the derivative, is 4x plus 2, 4x minus 7. 4x minus 7. So that's the derivative at any point. Now I want the derivative at 2. So I'll replace x with 2, and I get 4 times 2 minus 7, which is 8 minus 7, which is 1. So I get a 1. Alright, so now, we don't need that. We want the equation of the line. That's what the book asks us for. x1 and y1 are the actual location. So to get the actual location, I'm actually going to have to put that 2 into there. So I get 2 times 2 squared minus 7 times 2 plus 3. That's going to be 4 times 2, which is 8, minus 14 plus 3, so negative 6 plus 3, which is negative 3. Okay, so this gives me f of 2, so that's negative 3, so y plus 3, m, we just calculated, is 1, and then x is the 2, so minus 2. Now there's a lot of steps right here. We're going to solve for y, so we're going to subtract that 3, and we get x minus 5. That's the equation of the tangent line. That's our final answer. Now, I would recommend, before you do the derivative spot, if you're trying to find the equation of the tangent line, that you actually, as a first step, find your xy point. Find where this is. Where is it? I did that last, which I think is kind of confusing because finding the derivative is a little bit more involved, whereas finding this point xy is a very easy step, but it's easy to lose in the mix. Alright, so we found the equation of the line and we're done. Now, we did not have to find this equation right here. We wanted the derivative at a certain point. So we could have done an estimate. We could have said, well, our derivative is about f of x plus h, so we'll just add our, a little bit, minus f of 2, and done something like this, estimated it, and gotten something. And so if we do this, if I put in 2.001, this is just calculator work. So I put 2 times 2.001 squared minus 7 times 2.001 plus 3, calculator work, and the calculator spits out a number. And then we did this calculation already somewhere, 3, so plus 3, all over 0.001. My calculator, when I do this, spits out 2.002e negative 2, negative 3. That means move my decimal point 3 spaces to the left. Rather than do that, I'll just go ahead and divide by 0.001 and get about 1.002. So now this is where you really need to think. Is this actually what it is, or is it just getting close to 2? Getting close to 1. It is getting close to 1, right? So that's, by and large, a way faster way to get your derivative if you want it at a certain point. Whereas what we did is, the first time around, we found, well, what's the derivative everywhere? And we got our derivative of everywhere being this thing. And this is very powerful. If we can get this, it's very powerful, because then I can plug in any number I want and get the slope of the tangent line at any point. And I can get any number of these that I want. Alright, we're going to find the derivative of f of x equals 1 over x plus 2. We're going to find this derivative. So we're going to do a lot. This is going to be rather confusing. So we want this. We don't get to do it at a certain point. We want this, so we're going to have to do this limit stuff.
Why do you always put a 1 in front of that?
That means derivative. So this, look at the top right, f of x, that means function, y. This means the derivative of the function, so it's read f prime. This would mean the second derivative, do it again, f double prime. This, which we've already done before with a negative 1, that means the inverse function. Okay? So these have to do with derivatives. This is an inverse derivative. Okay? Those are the symbols. And actually, when we get into more derivatives, we'll actually also use this other thing called dy dx. And that's meaning the same thing, but this is going to be convenient for a different case that's going to come up. Alright, so we're going to find this derivative. We're going to replace x with x plus h. So we take the limit as h approaches 0. I am taking this and putting it into here, and I get 1 over x plus h plus 2 minus 1 over x plus 2 all over h. I need to somehow get the h's to cancel. I'm going to hold on to this right here, and I'm going to do a bunch of work down here that'll be eventually erased. But what I need to do is actually combine these fractions. So to combine fractions, hopefully you remember, that means I need a common denominator. So my common denominator is x plus h plus 2 times x plus 2. And I see that to get that denominator with this fraction, I need to multiply that 1 times x plus 2 minus, to get that denominator, I need to multiply this fraction by x plus h plus 2. Do you remember how to combine fractions? You good? Okay, so I'm going to go ahead and simplify this numerator. And I get x plus 2 minus x minus h minus 2 all over. I'm not going to bother expanding this just yet. The x's cancel, the 2's cancel, and that leaves me with a negative h. So I have negative h up here. All over x plus h plus 2 times x plus 2. Okay, so this is what this up here becomes. Okay, so equals limit as h approaches 0 of h. I have a negative h over this quantity x plus h plus 2 times x plus 2. Okay, now I'll erase all this. That was our work. That was a plus 2. And this is an h. Okay? Keep, flip, change. I'll actually do the division. So, negative h over x plus h plus 2 times x plus 2. This is a complex fraction. We can go ahead and do the division. Keep, flip. So it would be h, so it's 1 over h. And now we can cancel these. And I get a negative 1. Equals limit as h approaches 0 of negative 1 over x plus h plus 2 over x plus 2. Now, hopefully you see if I go ahead and evaluate this limit by replacing h with 0, I get x plus 2 times x plus 2. So I equals limit, well, I'm evaluating limits, so equals negative 1 over x plus 2 times x plus 2. And I could leave it like that, I suppose, but we'll go ahead and expand. And this is our derivative. So f prime of x equals this. Okay? That one was way harder. What made it harder? If you have fractions and you're doing the limit, you're going to go ahead and have to combine those fractions. All that to say. Let's do, I want to do radicals, but we'll save it. So you need to be able to do things on page number 762, 4 to 32, even. Number 48. Number 50, and that should be good.